Hello all, hope you are doing well. So I believe from whatever the last two questions we have discussed in earlier classes, so you have gone through that and you understood the concept behind these questions. So let's today discuss about question number 3. So just for your reminder, this was question number 2. Okay, so where we found x plus y plus z plus m equals to how much we found in the previous video. Okay, so kindly go through this video, the previous video, so you will get that. Okay, so today we are going to discuss question number 3. So what it is asking in the question number 3, it is asking if a and b are square matrices of the same order. Okay, then find out a minus b whole square equals to how much. Okay, so out of this 4 option, one option we have to choose. Okay, so if a and b are square matrices of the same order, so we know a square matrix is a matrix. Suppose I am writing a equals to is a square matrix if the number of rows must be equals to number of columns. How many rows will be there? Those many columns. If it is there in that matrix, then we can say it is a square matrix. So in this particular case, suppose I have given example of 5 cross 5, so means and 5 column, right? So such kind of matrices are known as square matrix. Okay, so if a and b are square matrices of the same order, it has not given us what is its particular order. Okay, so you can take m cross n, where m equals to n. Okay, then we can say that is a square matrix of the same order. Then what is the value of a minus b whole square? Okay, so it may look similar like variables whatever we learned in upper primary schools, like a plus b whole square formula, but it is not same as it is, because matrix multiplication is not the same way how we do with variables in algebra. Okay, so let's try to prove this one. Suppose in question it is given a minus b whole square. Okay, so now I can expand this way, a minus b whole into a minus b, because this is valid in matrix multiplication. In algebra, how we do it? In algebra we do it like x square, so we can write x into x, right? So similarly in matrix, how we can write? Suppose a square, so what is its meaning? Like a into a. Okay, because this both are same matrix. Okay, so if both are same matrix, then we can write this way. But for clarification, in question it has given that it is a square matrix. Suppose if order suppose I am taking another matrix b. Okay, so another matrix I am taking, that is b. Suppose its order is 3 cross 5. Okay, so if I want to calculate b square, how can I calculate? So I have to write b dot b, right? But here it is a matrix of order 3 cross 5. Okay, and I have to multiply with same matrix of the same order, like 3 cross 5. But during matrix multiplication, what we understood that, or what we learned, that the number of columns of the first matrix must be equals to the number of rows of the second matrix. So here in the first matrix, the number of column is 5, and in the second matrix, the number of rows are 3, right? So which is not equals, like 5 is not equals to 3. So that is why in this particular case we cannot multiply b with b. Okay, we cannot multiply b with b. That is the problem, and that is why in question it has given that a and b are square matrices. A and b are square matrices of the same order. Okay, so it is of square matrix and it is having same order. Okay, suppose here I'm taking b is, so c as another matrix. C equals to, I'm taking, suppose this is 3 cross 3. So now I can find out c square, because I can write here c into c. C square equals to c into c. And similar way I can write here, so it is a matrix of, first c is the matrix of order 3 cross 3, and I have to multiply with another matrix of same matrix c, and which is also having order as 3 cross 3, right? So now if you'll observe here, the number of columns in the first matrix is equals to the number of rows present in the second matrix. So now we can multiply c with c. So in this particular case, matrix multiplication is possible, but in this case it was not possible. In this case, like b was a matrix of 3 cross 5. So in that particular case, matrix multiplication was not possible, right? So that is why that hint has given in the question. So now I'm coming to the another hints of this question, like a and b are square matrices of the same order. Okay, suppose you are thinking like a is a matrix of order 3 cross 5. Oh, sorry, it is a square matrix, so we can take 3 cross 3. Okay, and b is a matrix of order, suppose I am taking 4 cross 4. Okay, so now A is a matrix of order 3 cross 3 and B is a matrix of order 4 cross 4, right? Both are square matrix, but both's order are not same. That is why whenever we will explore this one, whenever we are going to, I'll show you the proof, whenever we are going to multiply or we are going to expand this one. So in that scenario, we cannot multiply with A and B, because in this particular case I have taken A as a square matrix of order 3 cross 3 and B as a square matrix of order 4 cross 4. So that is why I cannot multiply A dot B, or I cannot multiply A with B. Okay, because there is a mismatch of dimension, or we can say order. Okay, so why? So if you'll see here, A dot B have to perform the matrix multiplication. So A is a matrix of order 3 cross 3, and I'm multiplying with B. B is a matrix of order 4 cross 4. Though both are square matrix, so according to matrix multiplication rule, or what we learned in the first, like the number of columns present in the first matrix is not equals to the number of rows present in the second matrix. 3 is not equals to 4. So that is why we cannot multiply A and B here in this particular example. Okay, the particular example I have taken here, though A and B are both square matrix, we cannot do the matrix multiplication, right? So that is why in question it has given very clearly that if A and B are square matrices of the same order, then you have to do the, or you have to find out the value of this one. Okay, so now let's see. So hope you recall the concept whatever you learned during your session. Okay, so now let's try to find out this answer. Okay, so here I can expand here a minus b whole square as a minus b whole into a minus b. This is possible because in matrix multiplication, as per the assumption that a is a square matrix of order same, right? N cross n. Okay, and B is also a square matrix of order same like n cross n here. Okay, so from that assumption or from that clarification we can expand this way. Okay, so now how we expand this multiplication? So first of all we will multiply A with this one and B with this one. Okay, according to distribution law. Okay, so what I'm trying to do here is I have to first multiply A with A minus B. Then minus B will be multiplied with A minus B. This one. Okay. So now again I have to apply distribution law. So A dot A I can mention. So A dot A. Okay. So now I can, what I have to write, A dot B, and that will be minus A dot B. And as I said earlier that A dot B or A multiplied with B is not equals to B dot A, even if though the order of both the matrix are same and both are square matrix. Though both are square matrix and their order is same, still we cannot write A dot B equals to B dot A. So A dot B not equals to B dot A. Okay, so we have to remember this rule in matrix multiplication, right? So that is why we can say here A dot B not equals to B dot A. That is the trick here. Okay, so then what we have to do here, now B is going to be multiplied with A, so minus B dot A. Okay, now minus that will be plus, and B dot B, this will be B dot B. Okay, so we can write this way, A dot A I can write A, and A dot B I can write AB, minus B dot A I can write BA, and B dot B I can write BB, or it is also I can write A square minus AB minus BA plus B square. That is what I can write. So earlier days, like when we learned A minus B whole square formula, we could have written here AB or AB equals to same as BA. AB same as BA. So in algebra, we were able to write this way because in algebra AB equals to BA. So that is true, but that is not true in case of matrix multiplication. Okay, for a better clarification, I can take an example and I can make you understand why A dot B not equals to B dot A. Suppose I am taking one example here. Okay, so A is a square matrix and it is of order 1 cross 2. So I am taking elements like that 1, 2, 3, 4. And B is also a square matrix of the same order. It is of order 2 cross 2, and B I am taking same order like 3, 4. Sorry, I can take here 5, 6, 7, 8. Okay, this is also having order same like 2 cross 2 or 2 by 2 or 2 cross 2, whatever way you want to read it. Okay, so suppose I'm performing matrix multiplication. Okay, A dot B. Okay, now this is possible because it is of having same order. So I can write here 1, 2, 3, 4. This is of order 2 cross 2 multiplied with 5, 6, 7, 8. This is of order 2 cross 2. So what we need to first of all, we have to check that the number of columns present in the first matrix must be equals to the number of rows present in the second matrix. So here as we can notice 2 equals to 2. 2. So meaning is the number of columns present in the first matrix is equals to the number of rows present in the second matrix. So that is why we can say that this matrix multiplication is possible. Then we have to apply the multiplication rule. 1 is going to be multiplied with 5, then we have to add it with 2 will be multiplied with 7. Okay, so this way. So let me write here 1 into 5 plus 2 into 7. This is the first element. Similarly, I have to write for the second element like 1 into 6 plus 2 into 8. So in the second, for the second element, this is going to be multiplied with this one and this is going to be multiplied with this one, and we have to add it, right? So we know this one. Okay, I'm just revising for you one more time. So 3 is again going to be multiplied with 5, 3 into 5 plus 4 is going to be multiplied with 7. So 4 into 7, 4 into 7. Now again 3 is going to be multiplied with 6, 3 into 6 plus 4 is going to be multiplied with 8, 4 into 8. Now we have to calculate its value. So in 1 into 5, 5 plus 2 into 7, 14. So that will be 5 plus 14, and this will be 6 plus 16, 2 into 8, 16, 3 into 5, 15, plus 4 into 7, 28. And here it will be 6 into 3, that is 18. That is 18. 18 plus 4 into 8, that is 32. That will be 32. Okay. So now here 5 plus 4, that is 5 plus 14, that is 19. And here 6 plus 16, that is 22. That is 22. 15 plus 28, that is 43. And this is 18 plus 32, that is 50. This is 50. And what we got is AB we got is this much. Okay, 19, 22, 43, 50. Now let's calculate BA. Okay, so we have to calculate BA here. Then first of all, I have to write the elements of B matrix. Then 5, 6, 7, 8. Okay, now I'm going to multiply with A. The elements of A are 1, 2, 3 and 4. Okay, so now let's perform the multiplication. So 5 and 6 is going to be multiply with 1 and 3. This one is going to multiply with this one, and this one is going to multiply with this one. Now finally we have to add it. Okay, so we know this one. Okay, so 5 into 1 plus 6 into 3. This is the first element. Now the next element or the second element I can say, that is 5 into 2 plus 6 into 4. Right? So this will be the second element. So 5 is going to be multiplied with 2 and 6 is going to be multiplied with 4. Okay, so now third element, that is 7 and 8 is going to be multiplied with this one. 7 is going to multiply with 1 and 8 is going to multiply with 3, right? This way. Then 7 into 1 plus 8 into 3, right? Then 7 into 2 plus 8 into 4, right? So you can, meanwhile you can check whether I'm going correct or doing anything wrong, mistake, anything, you just check. So here 5 plus 1, that is 5 plus 6 into 3, 18, and this will be 5 into 2, 10, plus 6 into 4, 24, right? and here 7 into 1, that is 7, plus 8 into 3, that is 24. 8 into 3, 24. So here then 7 into 2, that is 14, plus 8 into 4, that is 32. Right? So here 5 plus 18, that is 23, and 10 plus 24, that is 34, and here 24 plus 7, that will be 31, and 14 plus 32, that will be 46, and this is our BA. So when we multiplied B with A, and that is the result we got here, B and A here, BA. We can write here, that is 23, 34, 31, and 46. So it is clearly visible, and we can clearly notice that the elements of AB and elements of BA both are different. So when we say two matrices are equal, if every elements of or respective positioned elements of one matrix is equals to the respective elements of the other matrix, then we can say that two matrices are equal, right? So in this case, if you'll notice here, the I11, or I can say this is the 1 element, first row first column. So first row first column element is 19, and here first row first column is 23, which is not equal. So if at least one element is not equal, we cannot consider that two matrices are equal. So here you can see every elements are different here, like respective positioned elements are different here in both the matrix. So that is why we can say AB is not equals to BA. Like 19 is not equals to 23, 22 is not equals to 34, 43 is not equals to 31, and 50 is not equals to 46, right? So it is clearly proved that AB is not equals to BA. So we can write here AB is not equals to BA. AB is not equals to BA. This is an example I given here for your clarity or for better understanding, so that you can notice that even though there are matrices of same order, and though both are square matrix, then only also it is not possible that you are going to consider or you are going to compare both the matrices as equal. Okay. So what we observed here is, okay, so matrix multiplication is not commutative. Okay, though algebraic in algebra, variable variable multiplication is commutative. So matrix multiplication is not commutative. So what we concluded here is, taking a concrete example, that AB not equals to BA. Okay, so hope you understand and hope you got the concrete clarity about this one. Okay, now let's solve our actual question given in the exam. Okay, this is for your understanding. If you don't know also, in single video you will be able to understand everything. Now let's come to the question. Okay, in question what it is asking is, let's solve it. Okay, so I hope you got the clarity. So how we do matrix multiplication and what should be the answer of this question. So wherever this option is there, we have to pick that one. So which option? Option B. Option B is the correct answer. Okay. So option B is the correct answer. B. A square minus AB minus BA plus B square. Okay. So hope you enjoyed this. Let's see in next video with another question. Till that time, keep on practicing and best of luck for your exam.